Hi everyone. So far we've learned about how to use addition and subtraction in a proof. So you had to guess that we would eventually learn how to use multiplication and division in a proof. So that's what we're going to focus on in 2.6. So let's talk about multiplication first. So we have this multiplication property of equality, and we're going to abbreviate that to MPE. So MPE says that if segments or angles are congruent, then their multiples are congruent. So let's go through some examples of what that really means so we could see it a little bit more visually. So for the first example, we are told that E is the midpoint of AB, G is the midpoint of CD, and that AE is congruent to CG. So we can even put some numbers in here if we want. So let's say this is a length of 2 and that's a length of 2. If E is a midpoint, well then that must mean that it cuts line segment AB into two congruent parts. So then therefore this is also going to be a length of 2. And if G is a midpoint for the exact same reason, this segment is going to be a length of 2. So because we have two pairs of midpoints and we've got a pair of congruent pieces, what MPE does is it allows us to say that therefore AB, segment AB, is congruent to segment CD, and that's because of MPE. So if these two segments are congruent, they're multiples, right? So I'm multiplying this by 2. I'm multiplying this by 2 because of the midpoint. Their multiples must also be congruent. If this extended out and it was a trisection, and I was to take one piece and multiply it by 3, and this piece and multiply it by 3, again, the whole segment would be congruent to each other because you're multiplying it. It's the multiples are congruent. So we can actually do the similar thing with angles. So here I'm told that AG is bisecting angle BAC, CG is a bisector of angle BCA, and that angle 2 and angle 4 are congruent to each other. Well, again, let's put some numbers to it. So let's say these are both 30, right? If this whole angle is getting bisected, well, then this one is also 30. And if BCA is getting bisected, then angle 3 is 30 as well. So you'll see my two larger angles are now both 60. So by MPE, I could say that angle BAC is congruent to angle BCA, and that's because of our new reason. So I'm taking the multiples, it's getting bigger, and I am getting the larger pieces congruent. Division is very similar, except we're going the opposite way. We want to get smaller. So we have the division property of equality, DPE. So if segments or angles, again, are congruent, then their divisions are congruent. So here, I've got that S is the midpoint of PQ, T is the midpoint of RQ, and that PQ, so this whole big segment, is congruent to this whole side. So let's say these are each, 10 and 10. I'm just giving it numbers just to help you see it a little bit better. So if S is the midpoint of PQ, well then that must mean that PS is congruent to SQ. And if that whole thing is 10, then each of these is 5. Over here, T is the midpoint of RQ. So these two are congruent and they're both 5 again because the long sides are congruent to each other and both equal 10. So now you'll see if I take these larger pieces and divide it into its smaller section, I can therefore conclude that PS is congruent to SQ, which is congruent to QT, which is congruent to TR, and that is because of DPE. So again, double midpoint, double bisector, you're probably seeing a pattern here, another double midpoint. If I see a double use of these types of words, I can use DPE and MPE. So that's with segments. Let's look at with angles using DPE. So I've got another double bisector. You'll see I wrote here, look for double use of word midpoint, bisect, or trisect. That's like your key that you need to use MPE or DPE, probably. We're told that ABF is congruent to FCD, so these two larger angles are congruent. Use two lines for now. Okay, and I'm told that I've got two bisectors. So let's pretend that the large angles are, I don't know, let's say they're 100 each, 100 degrees. I know that BG bisects angle ABF. So that must mean that each of these are congruent. So those are going to be 50 and 50. CE is bisecting FCD. So again, these are congruent, both 50 and 50. So by DPE, I can therefore conclude that angle ABG is congruent to angle GBF, which is congruent to angle FCE, which is congruent to one more ECD, and that is by DPE. So if we're going from larger pieces to smaller pieces, we're going to use the division property of equality. So let's see, this was using numbers. Let's see how I can use this in a proof. So let's look at proof number 1. Mark up your givens, see if you can start the proof, and then we'll go over it together. Okay, so I marked up my diagram and I wrote my givens. So here I'm told that I have two midpoints. I know that F is the midpoint of AB. So actually what I could do is if this is represented by two lines, I can mark that off with the two hash marks because those two pieces are congruent if I have a midpoint. Same thing over here. If G is a midpoint of ED, then I can put my two hash marks to mark that up. So notice that I have a lot of little pieces, and I want to try and prove that these big sides, AC and EC, are congruent to each other. So since I'm going from small pieces to bigger pieces, I'm going to end up using the multiplication property of equality because I'm getting larger. So since I know that AF and EG are congruent to each other, and I have our two midpoints, well then that must mean that they're multiples, so AB and DE are also congruent by MPE, because I'm taking this piece really and I'm doubling it, and I'm taking this piece and I'm doubling it. And since AF and EG are the same, well then the larger pieces are also going to be the same. So I can state that in my proof. I'm going to say that AB is congruent to ED, and that is because of my new theorem MPE, multiplication property of equality. Now, you just also learned how to add segments and angles in your last section. So you'll notice I've got AB is congruent to DE. I've got BC is congruent to CD. The segment addition theorem, which we just learned, SAT, says if congruent segments are added to congruent segments, then their sums are congruent. So therefore, I can say that AC is congruent to EC because of my SAT, segment addition theorem. And that's it. So now I was able to prove that the smaller pieces, and then use the smaller pieces and MPE to get that the larger pieces are congruent. So maybe we want to just write here at the bottom that we want to use MPE when the segments or angles, because you can do this with angles as well, in the conclusion are greater than those in the given. So again, my AC and EC were larger than the pieces in the given. You can also phrase it as you're going from smaller to larger. So maybe we'll put that in a little bracket. Smaller to larger. Now let's see how we use DPE in a proof. So here's our second proof. Again, feel free to pause, give it a try first. I'm going to mark up my diagram and write out my givens. So I know that angle 3 and angle 4 are congruent, and I want to show that angle 1 and angle 6 are congruent. I'm also told that I have ABF and FCD being bisected. So I'm just going to mark that up here. I know that angle 1 then is congruent to angle 2, and then angle 5 is going to be congruent to angle 6. And the reason I'm using 2 markings is because I know that angle 3 and FBA are supplementary, and angle 4 and angle FCD are also supplementary. And if these are congruent, well, then their supplements must also be congruent to each other. So that's why I'm using the same markings right now. So everything I just stated with the supplements, that's all what I'm going to use in my proof to show that angle 1 is congruent to angle 6. So step 2, I know that if I'm going to use supplements, the first thing I always need to do is name that I have straight angles. So I've got angle ABC and angle BCD are straight angles. And we know that that's always because it's assumed. After I name my straight angles, I always want to name my supplements. So I know that angle ABF and angle 3 are supplementary, and angle FCD and angle 4 are supplementary. And that is because of SA sup. Now, the reason why I'm doing this is because you'll notice I know that 3 and 4 are congruent. Here they are again, they're matching up. So if you remember, our ST therefore states that angle ABF is congruent to angle FCD because of ST. So now I know that my 2 bigger angles are congruent, but I want to prove that their smaller parts are congruent. So I'm going from big to small, and when I go from big to small, I'm usually dividing. So because I've got that double use of the word bisects, I can therefore state that since the 2 angles are congruent, their multiples are congruent, or their divisions are congruent. So that's going to be my last step. Angle 1 is congruent to angle 6, and that's because of DPE, because we're getting smaller this time. So let's make a little note at the bottom, just like we did in the other one. We are going to use DPE when the segments, or the angles, in this case we did an angle problem, but it works with segments as well, in the conclusion are smaller than those in the given. So this time we are going from a larger piece to a smaller piece. And we look for those double use of the words midpoint, bisectors, and trisectors. And that's going to be our hint. Hey, I need to use DPE or MPE. So now we've covered all of our operations. We've got addition and subtraction with SAT and AAT. And now we have division and multiplication with DPE and MPE.